In this video, we shall learn about how to use R to fit a generalized linear model. First, we shall follow the footsteps of D.J. Finney and carry out a similar analysis without using any specialized generalized linear model tool from R. So let us create our data set. I have the doses. Suppose I use the doses 7 to 13. And n is the number of doses that I am using. So I have 7 to 13, and then I have n, the number of doses that I am using, which is 7. Now I will create a list of proportions of death, prop death. So I start that with an empty array and I create a matrix. That's my data matrix. My data matrix is going to have all the doses in the first column, and for each mouse, whether the mouse is living or dead, in the second column. So I will have as many rows in it as there are mice. Now I run a loop for I from 1 to n. So I am doing it for each dose. For each dose, I will take 100 mice. So for those 100 mice, I will have different actual lethal doses for those mice, the maximum that they can endure without dying. So I create them randomly. This is a simulation study. So I'm creating the mice randomly, or their lethal doses randomly, or norm 100, and I make the mean say equal to 0. So these are the actual lethal doses, my x1 to x thing in, where these are latent variables. In practice, I will not be able to see them. Okay, so I create them, and after that I have to see whether the mouse is living or dead for these 100 mice. So what I do is I take the ith dose level that I'm working with and see if it is greater than or equal to the lethal dose. If it is, in that case, the mouse will die. So dose is greater than or equal to lethal dose. That gives me a Boolean thing. So I am doing it for all the 100 mice in one line. So I create this dead, and then I create that part of my data matrix. So I am appending. So I am using this R-bind. I have my data matrix and it is growing. For each step, I am adding 100 additional rows to it, corresponding to the 100 new mice that I am deploying for this new dosage. Then inside that extra thing, I have a C-bind, where in the first column, I am just repeating the same dose I. In the second column, I am writing dead, true, false things. So that's the data that I create. And then finally, I compute the proportion of deaths that I get for that particular dose. Since dead is a Boolean array, so true, false, zeros and ones, if I just take mean, that will basically give me the proportion of ones. So I compute the proportion of death for the ith dose, and I come out of the loop. So I can just show you what I get. I have team mat, it is 700 by 2, 700 because I have got 7 doses. For each dose I have got 100 mice, and the two columns are, the first column gives me dose and the second column gives me dead or not. So I can just show you this mat. It's a huge thing. So you can see initially I'll have 0, 0, 0, which is a very low dose, because on an average it is near 10, and I'm giving it dosage of only 7. So all the mice are living initially. At 8 I had 1 death. I saw 1 death. Then I go on. At 9 the number of deaths is increasing. At 10 I have quite a few deaths. 11 more dead than alive. 12, 13, everyone is dead. And I can see that if I look at the proportion, so I can even plot the proportion of deaths again say dose. So I already have that command here, so I will do it from here. So I am plotting it, and you see the plot. This plot is definitely like the sigmoid curve, namely we are seeing that Gaussian CDF showing up. So that was the plan of DJ Finney. We have estimated the probabilities. If I plot, I should see this Gaussian CDF. So if it doesn't look like the Gaussian CDF, then that normality assumption is not good. But then we have to fit that Gaussian CDF to this, which was not very easy at that time. So what DJ Finney did was, he took phi inverse of that. Phi inverse is implemented in R as the Q norm function, quantile of normal. So now we plot those with Q norm. So I just do this, and you can see that now the graph is a pretty straight line. So you can just fit a line to it, and that's how basically DJ Finney did his first probit regression. Now this is a very crude method, and also if we try to apply our LM function to this to fit that line, we will see that something will go wrong. Let's just try it out. So we just try it out, and you will see, ooh, I have got an error message. The reason is, you see, when I apply the least possible dose, namely the least possible dose was 7, then not a single mouse was dead. So the proportion was 0, and you took phi inverse of that, that gives you minus infinity. And that minus infinity causes problem. Of course, you can avoid that. You can just set it something instead of minus infinity. You make it minus 3 or something. So this process is not entirely free of trouble. And also it's a very crude technique. Now the way we use it in the modern day is to use maximum likelihood estimate. And that's what I am going to talk about now. Now, when we want to fit a linear model, just a usual linear model, there are two pieces of information that we must specify to the computer. We have to specify the X, all the inputs together with the design structure, the design matrix, and the response Y. Now, when we are working with a generalized linear model, we have some extra things to specify. Number one, we have to specify what is the distribution of Y. In case of usual linear model, we just take it to be normal. Here, we have to specify what is that distribution that we are talking about. Secondly, we have to also specify how Y is connected with X. So earlier it was just Y equal to X beta plus epsilon. So the mean was directly X beta. But now we allow something more general. We allow expected value of Y to be equal to some function of X beta. So this function, this H function, which is called the link function, also needs to be specified. So when we want to fit generalized linear model using a computer, whether R or SAS or whatever, we have to specify 4 pieces of information. We have to specify the design matrix. We have to specify the response, the data. We have to specify the distribution, or rather the family of distribution. We have to specify the link function. So we need to understand how to specify these 4 pieces of information before we can fit a generalized linear model using R. So let us see how we can specify those 4 pieces of information to R. We shall again work with the same data set, but now we shall first pack them into a data frame. So I create the column names. So I already had mat. I create the column names dose and death. So death is a binary variable, 1 or 0 or true or false. So I create that. And then I turn this into a data frame. I call it dat. So now dat is a data frame. So let's quickly see the first few columns, the first few rows. It is doses 777, all the mice that we can see here are living. Now I have to go into the fitting of GLM. Fortunately for us, we do not need any additional package for GLM. It is just like LM. So GLM is also the name of the function that we need to use. Here, the first thing we specify is Y, that is death, which is a binary thing. Then I write, and observe that I do not have to say as dot factor. So though these zeros and ones are coded as numbers, I really do not need to say that they are factors, because in the specification of GLM, when I say that I am working with a binomial family, it will automatically understand that these are factors. So I write death, that means I am specifying Y. Then I put a tilde, just like LM. Whatever I run after that will specify the inputs to my black box. They will constitute the design matrix. So in the usual way, so when I just write dose, it understands 1 plus dose, intercept and all the doses. So that finishes specification of Y and capital X. Of course, I have to specify my data set, which I call DAT. Now I have to specify the family of distribution as well as the link. I write down the family as family equal to binomial. So that is the binomial family. I could have even said Bernoulli, that is possibly would have been better, but that's the terminology that R uses. And the link is probit. So this is how I specify the family and the link. Just a little subtle point. Observe that I am not writing family equal to binomial, comma, link equal to probit. But link is occurring inside binomial. And that is because binomial allows only certain types of links. It is not that you have a bunch of families and a bunch of links and you can mix and match them whatever way you like. For binomial, you have only certain things. You cannot use some certain other things. So, this link specification comes inside the family specification. It's something like an idiosyncratic nature of R, but that's what it is. So let's just execute it pretty fast. It did something. Of course, you can look up the summary, but let's just see if I do an AB line of the coefficients. So the thing is very much like LM. I can just show you what's inside fit. There are plenty of things. Certain things will be recognizable. We have got QR, we have got coefficient, we have got residuals. All those stuff are there, rank, fitted values. There is something called deviance. Deviance plays the role of those sum of squares. So here sum of squares do not make much sense because we are not working with the L2 norm anymore. The deviance has to do with minus twice log likelihood and all those stuff. We are not going to go into those things here. But I can still extract the coefficients and draw a line. So I will do that. I will do it. So let's take a look at the line that I got there. So I earlier had these points by plotting the points in the Finney way. And now I get it the GLM way and I fitted a line, and the line is a pretty good fit. And we saw that simple LM could not work here because I got phi inverse of 0, which was minus infinity. No such problem here. And GLM basically uses maximum likelihood estimation or similar such sophisticated optimization techniques instead of merely trying to fit a line to the phi inverse values. Now, if you are interested in knowing about all the other families and links that are available, a good place to look at for them is to see the help for family. So if you see that, you will see that there are plenty of things that it allows. You have binomial. The default link for binomial is logit because that's what most people use most of the time, especially in finance and banking sectors, etc. You can also have Gaussian distribution with link as identity. That is precisely same as your original LM. So that is a special case of GLM. You can use gamma with a link called inverse, something called inverse Gaussian. Link is this. You can use partial regression. Then the link is log, and you can have lots of different such things. Suppose you are interested in knowing all the links that are available for binomial, then what you can do is you can go back to the command prompt and just try something like binomial. Will it work? Let me just see. Yes, you can see binomial, and it says all the different things that are available. I guess it has just redirected you back to that same page, but somewhere they have a list of all the things that binomial will allow. I am not sure where it is, but you can just do a little bit of search and figure out all the different link functions that binomial will allow. So, not sure where to find it. Let me just try link. No, unfortunately it also comes to the same place. But there is some place where you can see all the possible links that binomial will allow, and you can also create your own family and own link. But we are not going to go into details of those things.